If we touch a silent bicycle bell, we do not find anything special in it. But let us now touch the bicycle bell after ringing it. We will find that the ringing bicycle bell is vibrating. That is, it is moving back and forth continuously through a very small distance. Now, if we hold this ringing bell tightly with our hand, it stops vibrating and the sound coming from it also stops. So it is clear that when the bicycle bell is vibrating, it is producing sound, and when the bicycle bell stops vibrating, the sound also stops. So from this we may conclude that sound is produced when an object vibrates, that is moves back and forth rapidly. In other words, we may say sound is produced by vibrating objects. Whenever we hear a sound, then some material must be vibrating to produce that sound. A vibrating object which produces sound has a certain amount of energy which travels in the form of sound waves. The energy required to make an object vibrate and produce sound is provided by some outside source like our hand, wind, etc. The buzzing sound of a bee or mosquito is produced by the vibration of their wings. The sound in a sitar, veena or guitar is produced by the vibration of the straight strings. Or the sound of our voice is produced by the vibration of the two vocal cords in our throat, which is caused by air coming from the lungs. The sound of a drum or tabla is produced by the vibration of its skin or membrane when struck. The sound of flute, the bansuri, is produced by the vibration of an air enclosed in the flute tube. The sound of school bell is produced by the vibration of an iron or brass plate when it is hit by a hammer. And the sound in a radio or television is produced by the vibrations of the three diaphragm of the speaker. In most of the cases, a sound is produced by an object when it vibrates. It vibrates so fast that we cannot see its vibration with our naked eyes. So what do we conclude from this? We actually conclude that sound can be produced by vibrating strings, as in the case of a sitar, guitar, or maybe by vibrating air in the case of a flute. It can also be produced by vibrating membranes, as in the case of drum, dholak, or by vibrating plates, as in the case of manjira, which we call Campbell's. Let us now explain how sound reaches from a vibrating body or the source of sound to our ears. When an object vibrates and makes sound, then the air layer around it also start vibrating in exactly the same way and carry sound waves from the sound producing object to our ears. Suppose a tuning fork is vibrating and producing sound waves in air. Since the prongs of the tuning fork are vibrating, the individual layers of air are also vibrating. Sound travels in the form of longitudinal waves in which the back and forth vibration of the air layers are in the same direction as the movement of the sound wave. The substance through which sound travels is called a medium. The medium can be a solid substance, a liquid, or a gas. Solids, liquids, and gases are called material media. Sound needs a material medium like solid, liquid, or gas to travel and be heard. In other words, sound can travel through solids, liquids, and gases but it cannot travel through vacuum, that is empty space. Please note over here that sound waves are called mechanical waves because they need a material medium like solid, liquid or gas for their propagation. The sound waves involve the vibration of the particles of the medium through which they travel. On the other hand, light waves and radio waves are called electromagnetic waves because they do not need a material medium for their propagation. They can travel even through vacuum. An electromagnetic wave involves the electric and magnetic fields of the empty space. For this discussion, we can conclude, though sound waves cannot travel through vacuum, but light waves and radio waves can travel even through vacuum. If a train is very far away from us, we cannot hear its sound through the air. But if we put our ear on the railway line, then we can hear the sound of the coming train even if it is quite far away. This shows that the sound can travel through the railway line, which is a solid substance made up of steel. In fact, sound travels about 15 times faster in steel than in air. Now let us take another example. The little children in our homes use the toy telephone in which two tins are connected by a thread. If a child speaks into one tin, he can be heard by another child who puts his ear to the other tin. In this case, the sound vibrations are transmitted through the thread, which is again a solid. Let us now try to describe an experiment to show that sound can travel through liquids. Let us take a piece of squeaking toy, not those toys which make sounds, in a polythene bag and hold it in a bucket full of water. We put our ear to the side of the bucket and squeeze the toy. We can hear the squeak. This shows that sound can travel through water, which is a liquid. In fact, this very fact has been used in the detection of submarines which are hidden under the sea. The sound of the engines of submarine is transmitted through the sea water, and this sound is detected by special hearing aids called hydrophones. Let us now take some examples from daily life which will show that sound can travel through gases. When the telephone bell rings in our home, we can hear its sound even from a distance. In this case, the sound of the ringing telephone bell travels to us through the air in the room, which is a gas or rather a mixture of gases. When we talk to a person standing near us, then the sound of our talk travels to the other person through the air around us. The sound of radio, television, motorcars, buses, trains, aeroplanes, and chirping of the birds all travel through the air and reach our ears. In fact, most of the sounds which we hear in our everyday life reaches us through the air. So these observations will actually tell us that sound can travel through air. So we can conclude that sound can travel through solids, liquids, and gases. A material medium like air is necessary for the transmission of sound. Sound cannot travel through vacuum or empty space. Well, we can explain this with a small experiment. A ringing bell is placed inside an airtight glass jar, which is also called a bell jar, containing air. We can hear the sound of the ringing bell clearly. Thus, when air is present as medium in the bell jar, sound can travel through it and reach our ears. The bell jar containing the ringing bell is now placed over the plate of a vacuum pump. Air is gradually removed from the bell jar by switching on the vacuum pump. As more and more air is removed from the bell jar, the sound of the ringing bell becomes fainter and fainter. And when all the air is removed from the bell jar, no sound can be heard at all. Thus, when vacuum is created in the bell jar, then the sound of the ringing bell placed inside it cannot be heard. This actually shows that sound cannot travel through vacuum. If air is now put back into the bell jar, the sound of ringing bell can be heard again. So we can conclude that air is necessary for the sound to travel from the ringing bells to our ears. Would you be interested to know how it actually happens? Well, when clapper, that hammer that is there, the clapper hits the bell vibrates and makes sound. The vibrating bell makes the nearby air molecules to vibrate back and forth. These vibrating air molecules make the next layer of air molecules to vibrate, and so on. In this way, ultimately, all the air molecules around the ringing bell start vibrating back and forth. The vibration of air molecules present inside the bell jar are transmitted to the outside air molecules by the glass wall of the bell jar. Due to this, the air molecules outside the bell jar also starts vibrating in the same way. When these vibrating air molecules fall on our ears, we can hear the sound of the ringing bell. If, however, there is no air in the bell jar, then the vibrations of the ringing bell cannot reach our ear, and hence we cannot hear the sound of the ringing bell. So, when there is vacuum in glass jar, there are no air molecules to carry sound vibrations. We must note over here that sound can travel through solids, liquids and gases because the molecules of solids, liquids and gases carry the sound waves from one place to another through the vibrations. Sound cannot travel through vacuum because vacuum has no molecules which can vibrate and carry sound waves. The moon has no air or atmosphere at all. It is all vacuum or empty space on the surface of the moon. Sound cannot be heard directly on the surface of moon because there is no air on the moon to carry the sound waves or the sound vibrations. So we cannot talk to one another directly on the moon as we do on earth, even though we may be very close to each other. Similarly, there is no air or any other gas present in the outer space to carry sound waves. It is all vacuum in outer space, due to which sound cannot be heard in outer space. Thus, the astronauts who land on moon or walk in outer space are not able to talk directly to one another. The astronauts who land on moon or walk in outer space talk to one another through wireless sets using radio waves. This is because radio waves can travel even through vacuum, though sound waves cannot travel through vacuum. Sound takes some time to travel from the sound producing body to our ears. The speed of sound tells us the rate at which sound travels from the sound producing body to our ears. The speed of sound depends on a number of factors. The first one is it depends on the nature of the material or medium through which it travels. The speed of sound is different in different materials. For example, the speed of sound in different materials like air, water, and iron is different. At room temperature, the speed of sound in air is around 344 meter per second. The speed of sound in water is about 1500 meter per second, and the speed of sound in iron is 5130 meter per second. In general, sound travels slowest in gases, faster in liquids, and fastest in solids. If we convert the just given speeds of sound in air, water, and iron from meters per second to kilometers per hour, we will find that the speed of sound in air is 1238 kilometers per hour, while that in water is 5400 kilometers per hour, and the speed of sound in iron is 18,468 kilometers per hour. The second factor on which the speed of sound depends is temperature. For example, the speed of sound in air at a temperature of 0 degrees centigrade is 332 meter per second. The speed of sound in air at a temperature of 20 degrees centigrade is 344 meter per second. In fact, as the temperature of air rises, the speed of sound in it increases. Thus, the speed of sound in air will be more on a hot day than on a cold day. The third factor on which the speed of sound depends is the humidity of the air. For example, the speed of sound is less in dry air but more in humid air. In other words, sound travels slower in dry air but faster in humid air. In fact, as the humidity of air increases, the speed of sound through it also increases. From the table, we can say that the speed of sound in air at room temperature is 344 meters per second, which is written as 344 m by s. This means the sound travels a distance of 344 meters in 1 second through air at the room temperature. Sound travels faster through water than through air. For example, the speed of sound in water is about 1500 meters per second. Thus, sound travels about 5 times faster in water than in air. This means that sound can be heard very fast inside water. The fact that sound can be heard very fast inside water is used by creatures living in seawater to communicate with one another, even when they are far away from each other. For example, two whales, which are even hundreds of kilometers away from each other under the sea, can talk to each other very easily through seawater. The sound of their talk is carried by seawater very rapidly due to high speed of sound in water. Many objects such as aircrafts, bullets, and rockets travel at speeds which are greater than the speed of sound in air. They are said to have supersonic speed. Thus, the term supersonic refers to the speed of an object which is greater than the speed of sound. For example, when an aircraft flies with a speed greater than the speed of sound, it is said to have a supersonic speed. Due to its very high speed, a supersonic aircraft produces extremely loud sound waves called shock waves in air. The shock waves produced by a supersonic aircraft carry a great amount of energy. The tremendous air pressure variations caused by the shock waves produce a loud burst of sound called sonic boom. Let us now define what is sonic boom. Sonic boom is an explosive noise caused by the shock waves from an aircraft or any other object which is traveling faster than the speed of sound. The speed of sound in air is about 344 meter per second, and the speed of light in air is 3 crore meter per second, or we can call it 3 into 10 to the power 8 meter per second. It is clear that the speed of light is very great as compared to the speed of sound. So though sound may take a few seconds to travel a distance of 100 meters, light will take practically no time to reach a distance of even a few kilometers. Let us take few examples from our day-to-day life where the low speed of sound in air but very high speed of light is observed. The first example that comes to my mind is during the rainy season, the flash of lightning that is seen first and the sound of thunder is heard a little later, though both produced at the same time in the clouds. It is due to the fact that very high speed of light that we see the flash of lightning first, and it is due to the comparatively low speed of sound that the thunder is heard a little later. Even in the game of cricket, the ball is seen to be hit by the bat first and the sound of hitting is heard a little later with the same reason. Even uh, the gun, when it is fired from a distance, we see the flash of light first and sound of gunshot is heard a little later. We have the same reason because the speed of sound in air is only 344 meter per second. The speed of light in air is 3 crore meter per second. From these observations, what we find that light reaches us from a distant object instantly because of its great speed, but sound takes a little more time to reach us from the same object due to its low speed. Thus, it is the light which wins the race between light and sound.